Hello. This lecture is based on the pretty influential essay Observation by N.R. Hanson from the late 50s. So I often say in my philosophy of science class that science is an epistemically superior method for gaining information, gaining knowledge about nature. And what I mean by epistemically superior is that the knowledge is just more reliable, and that's more reliable than kind of our own, common sense or relying on past authority, or just your own sort of individual way of figuring things out. Those things are not always bad. They can be good. But if we want to have really high confidence that the information that we're gathering, the knowledge that we're building about nature, about the outside world, if we want to have high confidence in that, then it's science that we need to use. That's what makes it epistemically superior. And the epistemic superiority of science is thought to be based on these three things. And I bring this up in class now and then, that it's based on first observable empirical evidence. And by empirical, we mean that's just gathered through our sensory systems, vision, hearing, taste, touch, and so on. We'll focus almost exclusively on vision here because that's obviously our dominant sensory system. But the things that we talk about here can be expanded to include hearing and taste and touch and so on. The other thing that the epistemic superiority of science is based on is its rigorous testing, which we can talk about in a different video, and logical reasoning, again, which we would talk about in a different lecture, different video. And since the title of Hanson's essay is Observation, obviously we're talking about this first one. And for us to be getting good empirical evidence that can be used in science, that those observations need to be public, first of all. That is, everybody needs to be able to share in them. It can't be sort of your own private observation that you had kind of all by yourself, or only you are capable of having this observation. That's not going to qualify as good scientific empirical evidence that we can use. So it's got to be such that we can sort of all gather around the thing that we're looking at, some piece of evidence or something like that, and agree as to what we're looking at. Then it's also got to be repeatable, especially if it's experimental evidence of some kind. It can't be something that just happened one time, because we never know what quirky thing might have happened, some accident happened to make this one-time occurrence. And that might be worth investigating and looking into if it was really interesting. But nevertheless, if we're going to finally decide, yes, this is good empirical evidence that we can use to support our hypotheses, support or refute our hypotheses or our theories, then it's got to be repeatable. And so that's the kind of evidence that we're looking for to help make science epistemically superior. Now, there was this old assumption going, way back. Maybe this was something that always was an assumption until relatively recently. But the assumption is that there is a specific, correct, objectively accurate way to perceive the world. That is, our sensory systems are giving us just sort of straightforward factual information about the way the world is and about sort of what's laid out in front of us. So our vision, our visual system is just giving us, the straightforward facts. And then, of course, people are just going to disagree about things. Certainly scientists are going to disagree with each other about things, and they're going to disagree with non-scientists about things. And the assumption was that any disagreement comes after the basic perception, right? That everybody kind of perceives things in the same way, unless somebody's got a problem with their vision, they're blind or they're colorblind or something diagnosable is wrong with their sensory systems. But as long as your sensory system is working properly, we'll all sort of perceive things the same way. And any differences come in the later interpretation of those perceptions, or the understanding or the categorization of those perceptions. All of that comes after the basic perception, and that basic perception is the same among everybody. So the assumption had been. But the stuff that comes after the perception, the interpretation and so on, those are considered to be theory-laden. That is, they're influenced by your background assumptions. If you're a scientist, or even not a scientist, if you've got a theoretical approach that you're using, some theory about your research, your area of research that you accept, that's going to influence the way you interpret your perceptions. And that's sort of straightforwardly obvious. That's not really a controversial claim, that our background theories will influence the way we understand and interpret and categorize the things that we're perceiving. But as we will see here, Hanson is questioning this old assumption. Is it really true that everybody, as long as your sensory systems are functioning properly, that everybody perceives things in the same way? Is that really true? Or will people that are sort of observing the same thing, right? They're kind of all gathered around and looking at the same thing that's in the world in front of them. Will their perceptions of that thing be different from person to person? Maybe their background can influence the way that they perceive things. Maybe even their basic perceptions could be theory-laden. And Hanson is, not surprisingly, going to say, no, there isn't a specific way that everybody perceives things. There's not one objectively correct way to perceive the world, and that as long as your sensory systems are working properly, you will perceive it the same as everybody else. No, he says that our perceptions, what he calls visual perception, he calls seeing, that at least partly does depend on our previous experiences and sort of what assumptions and beliefs you bring into the situation. And if you're a scientist, what theories do you accept about this area of research that can influence not just your understanding and interpretation of what's in front of you, but your basic perception of what's in front of you. And it could be useful to think of some examples that you've come across where people just perceive things differently, that you can sort of say, oh, I see it this way. The other person says, oh, I see it that way. And there doesn't seem to be a way for you to figure out sort of who's objectively correct in perceiving this. In class, we certainly can talk about a variety of examples here. And I don't know how helpful this is, but just to kind of reinforce what we're talking about here, to sort of go through how visual perception and then the understanding kind of works, and so kind of how the information flows. We start with something out in the world that we're looking at, right? The object, the physical thing that's actually out there in front of us. And the idea is, of course, you got to shine light on it in order to be able to see it, and that light reflects off the object, goes through the lens of our eye, hits our retina in the back of our eyeballs, where our photoreceptors are, so that picks up the basic information about what photons, right, what colors of light and so on are coming into our eyes. And then that information is carried from the optic nerve into our brain, and our brain does some basic visual processing to figure out, what colors are there, where's edges and curves and motion and all that kind of stuff. And that generates the basic perception, the visual perception of what's in front of us. And to reinforce, the old assumption was that everything up to this point, unless you've got some diagnosable problem, like your optic nerve just isn't working, or you're missing certain photoreceptors on your retina, as long as nothing like that's going on, then everything up to the basic perception state is the same for everybody, that we'll all have the same basic perception of what's in front of us. And then after that, we go through this process. Maybe it happens very quickly and then continues on for some time, but after the basic perception, then we get kind of the recognition of what we're looking at, our interpretation of what we're seeing, and our understanding of it, and our categorization of it. And all of that, of course, there can be dramatic differences from person to person, depending on their background, their theoretical background, maybe their cultural background, their language background. There's all these different things that go into influencing the way that we recognize, interpret, understand, and categorize our perceptions. So the old assumption was that our basic perceptions are going to be the same from person to person, regardless of background. Now, we can also, we've got a bunch of examples that I'm going to show you here, and many of these maybe you've seen before, to show us that our sensory systems don't actually just give us straightforward facts about the world, right? That, yes, we maybe know that our sensory systems aren't 100% reliable. If you're not paying close attention or you're tired or something, maybe you might misperceive something and then you do a double take and you're like, oh, that's what it was. I made a mistake and now I understand what it is. But even then, even when you're trying to be careful and you're really focusing your attention, still your sensory systems do not always just give you straightforward, factual, objectively correct information about the outside world. So I've got a bunch of examples here, and we'll kind of build up the examples a little bit and make them more complicated as we go along. This one, you can try it if you'd like. It's best done in class, so we'll talk about it more in class. Okay, so here's some optical illusions that maybe you've seen before. So this one over here on the left, which line is longer? It certainly looks, our basic perceptual, visual perception of these lines is that the bottom line is longer. It just looks longer. It's not that we're interpreting it as longer or anything. It's just our basic perception of it is that it's longer than the top line. But, and you can check this out with yourself, get a ruler or something and test them, but these two lines are exactly the same length. It's just those weird line segments on the edges that make it look like the bottom one's longer. Similar things going on with the circles down here, which is bigger, which central circle is bigger, the one on the left or the one on the right. It looks, just by just looking at it and seeing these circles, our perception is such that it really seems like the one on the right is bigger, but it's not. Again, you can measure it yourself if you'd like. These central circles are exactly the same size. And it's just the circles around it that are messing with us. Then this image over here on the right, it really looks like, when you just sort of look at that whole image there of the sort of the checkerboard, the offset checkerboard kind of, it looks like those lines are wavy or they're somehow angled relative to each other, but they're not. It really looks like they are to me and to most people that I've shown this to, but they're not. And you can get a straight edge and hold it up to this image if you'd like to prove to yourself that in fact these lines are all parallel. Here's another example of that. These blue strips, when you just look at the whole image, it really looks like those blue strips are angled relative to each other, but they're not. They're perfectly parallel. Again, get a straight edge, prove it to yourself. But our perceptions are fooled. Our visual perception is not giving us the truth, right? It's not giving us an accurate, objectively correct representation of what's in front of us here. Here's another one. I really like this one. As you look at this, and maybe if you're looking at this on a small screen, it doesn't work as well. But if it's a big enough screen, it really looks like there's black dots at some of the corners of these intersecting lines, at the corners of these squares. But then when you try to focus on one of the black dots, it turns white and just stays white. And it turns out that there are no black dots in this image at all. It's just set up to kind of mess with your sensory systems to make you think that there's black dots kind of off to the sides a little bit. But every time you focus your central vision on one of these corners, you see that it's actually just a white dot. So again, not giving us accurate information, right? Our sensory systems are not perfectly reliable. This one's really interesting. It really looks like these spirals are kind of twisting and turning relative to each other, especially, as I'm talking and my head is vibrating a little bit. I think that kind of amplifies the effect. But it turns out this is a completely still image. There's no animation here at all. It's just your basic perceptions are wrong, right? Your basic perception is perceiving some kind of twisting, spirally movement, but there's no movement there at all. So here's a video that many of you have perhaps seen before, but we're taking it kind of up to the next level here. The previous examples were relatively straightforward optical illusions to show that our sensory systems are not giving us just basic factual information. Here, this video shows us something about how our assumptions can influence our perceptions. So I'll just play the video here because it's best viewed fresh.
This is a test of selective attention. Count how many times the players wearing white pass the basketball. How many passes did you count? The correct answer is 15 passes. But did you see the gorilla?
Yeah, obvious once your attention is drawn to it.
This video?
But the idea here is that your assumptions, you're sort of set up to assume certain things about this video that focused your attention only on certain parts of it, and you completely missed. Maybe you saw it, but most people, when they first see this video, they completely miss the person in the gorilla suit that walks right through the middle of the scene. And so this shows how even something relatively straightforward, like a gorilla walking through, can be completely missed if you're bringing certain assumptions and beliefs into the situation. And so it can dramatically affect the way you perceive a scene.
Video is from research.
Here's some more examples. These symbols perhaps most of you are familiar with these symbols. And when you perceive them, when you just look at them, your visual perception certainly includes the visual elements, right? This one on the left, it's a thick bordered triangle with a yellow interior and these black blobs and a circle in the middle of the triangle. But it's more than just that, right? It tells us caution. This is a caution symbol, right? Potential danger is in front of us. And if you're familiar enough with this symbol, then it's not as if you perceive the visual elements, and then after you're done doing that, you have this interpretation of the symbol. It's like, oh, this means caution, so I should be more careful. No, the caution of it is kind of part of the perception itself, if you have experienced the symbol enough. Same with the one in the bottom middle, this traffic control signal. The idea that it's a traffic control signal is just part of the perception itself. If you had never seen a traffic control signal, right, a stoplight like this before, then you just see the colored circles and the diamond shape and the yellow background and so on, and that's it. But if you're at all familiar with, especially in the United States, the way they set up, red, yellow, and green lights for traffic control, then your understanding of that is just part of the basic perception itself. This one on the right, if you work like in a hospital laboratory or something, then you're very familiar with the biohazard symbol. So that just sort of means biohazard. Right? The biohazardness of it is just part of the perception of the symbol itself. Now, those might be a little unfamiliar to you, so consider these. The one in the top left here, we've got a horizontal line segment, a vertical line segment, and then a little curve that's attached. It's like, yeah, that's the basic perceptual visual elements of it, but I don't perceive those bits of it and then after that interpret it as the number 5. Like, no, it being the number 5 is just part of my visual perception of it itself, just right there in the perception. There's no like extra step for interpreting it as being the number 5. It's just 5. Same thing bottom left here, this weird curve with the dot underneath, like that's just a question mark. It just is questioning. It just looks like a question to me. I don't interpret it as being the symbol that's at the end of a question. It just sort of is questioning. Maybe these whole words are a little more complicated, but nevertheless, the idea is that you don't just see the perceptual elements of this word and then interpret it as having to do with houses. You just sort of perceive house right there in the string of symbols itself. And if maybe you're doubting that, compare that to these symbols. Right? I just did a Google search for symbols in different languages that I'm not familiar with and picked ones that I thought looked cool. Right. And so I don't know Hebrew, I don't know Chinese, I don't know Arabic, any of those. So these are just visual symbols to me. That's it. That's all I see. I see, just the interesting curves and the shapes to these symbols. And that's it. But a native speaker of the relevant language here would have much more involved in their perception of these symbols, just like this, that the number 5 here, its 5-ness, so to speak, is just part of my perception of it. Whereas these, I'd have to look them up, or if I was a novice in Hebrew or Arabic or something, I would see the symbol and I'd still have to go through this interpretation step in order to understand it more fully. But if you're a native speaker or you're very fluent in one of these languages, and especially reading one of these languages, then your understanding of it, of what the semantic meaning behind it, just part of the basic perception itself. I've got a more controversial example coming up here. That's more of like your cultural background. So this one, a very politically charged symbol to be sure in the United States, that for some people, when they look at this, part of their perception is maybe kind of pride in their cultural heritage one way or not, in the long history in the area where they live. Whereas for others, when they look at this, they immediately have sort of a cringy reaction. That's part of the perception itself, is something about oppression and slavery, maybe even violence. And so people with different backgrounds can have very different perceptions of this. They can maybe agree as to how many stars are there and what the colors are, but it's more than that. They perceive this in a very different way. Okay, so of course, this is ultimately supposed to be about science, right? And that's what Hanson was writing about. All those examples I gave was just to sort of reinforce this idea that first of all, our sensory systems don't just give us objectively straightforward, factually correct information about the outside world. And secondly, that our background knowledge, our cultural beliefs, our cultural background, our educational background, our theoretical backgrounds can have an influence on the way we perceive the things that we're looking at. And this can then be extended into the science world, that certainly a difference between an expert in a field of science and somebody who's just getting into it might perceive things quite differently, right? Like the introductory student in a biology class, when they first look through a microscope at some cells on a microscope slide, they'll see some colors and some shapes and so on, but that's about it. But a microbiologist, right, a professional microbiologist, when they look through that microscope, they see way more. Their visual perception is different than the novice introductory student because they just have so much more background knowledge about what they're looking at. And that can influence the way they perceive what they're looking at through the microscope. And that's maybe a lesser point, right? But what Hanson is more worried about, right, where he gets actually sort of concerned about this, is when he's thinking about two different experts or two different groups of scientific experts in a certain field of research, and they believe in certain theories, right? They have different theoretical commitments in the two different groups of scientists, and they're all kind of gathered around looking at a certain kind of evidence that is important for understanding their theories, right? It might support one theory, but not another theory. But this group of scientists that believe in one theory might perceive what's in front of them a certain way. The group of scientists that believe in a different theory might look at that same evidence and perceive it in a different way, right? Now, again, there's no controversy. There never has been any controversy over the idea that the two groups would interpret those perceptions differently, right? Interpret the evidence differently and understand it, explain it differently. But the point here is that their basic perceptions might be different. The starting point, the basic information they're using to help support or refute their hypotheses or their theories or whatnot, that basic starting point might be different for people with different backgrounds. So, this is a real worry for science. If there's no objective truth about what we're observing, no agreement about the basic starting point, our basic perceptions of our evidence that we're gathering, then there's kind of no hope that we're ever going to come to a reasonable agreement about how to understand and interpret this stuff, right? They'll just never, it's like we're living in different worlds. And so this could be a real problem for the success and the progress of science. So, going back to the original assumption here that, our basic perceptual or visual system, our hearing and taste and touch and so on is just giving us straightforward factual information, that might turn out to be wrong, that our basic perceptions are theory-laden. that perceptions are heavily influenced by your background, by your theories that you believe in, by your cultural background, and so on. And so left over here is the question of really how serious is this? Is this a really big problem for science? Or is it something that scientists can overcome? How do scientists try to overcome this problem? How do they try to gather their evidence in a way to decrease the chances that scientists from different groups are going to disagree about what the basic evidence is, that they're going to perceive the evidence differently? What do scientists do to try to minimize that effect, to make it much more likely that scientists will all agree as to what the basic evidence is, and then go through the debate about disagreeing over interpretation and understanding and so on? So that's something that we can certainly talk about in class. Thanks.